what's great about Unit 5 is that it starts off with systems of inequalities, but really it just starts off with graphing again, which I think is a really good practice for us to do again. So we're just going to start with graphing lines, okay? Graphing normal lines. So remember, when we're graphing lines, I have 3 rules. Rule number 1 is that the line must be straight. That's why you have a ruler. Rule number 2 is that the line must have how many points? 3. The line must have 3 points. 2 points make a line. 3 points make a Miss Adams line. The only time you might not have 3 points is if the graph actually isn't big enough for 3, then 2 is fine. And then number 3, you need arrows on both ends of your lines, okay? And your line needs to go all the way to the edge of the graph, okay? So we're going to start with number 1. And so so remember, when we graph lines, we want it to be in slope-intercept form. So y equals mx plus b. And what does m stand for? M is the slope. And the slope is the rise over the run, right? Yeah. And then what does the b stand for? Y-intercept. The y-intercept, which is where the graph crosses the y-axis, right? Yes. So in number 1, what is my slope?
Negative 3 over 1.
Negative 3 over 1. So that means I'm going to go down 3, right 1. Would you agree?
Would it ever be a negative 1 under that or no?
You could do negative 3 over 1 or 3 over negative 1. The negative just has to be on the top or on the bottom, not both.
Okay.
Yep. And then what is my b value? What's my y-intercept? 2. So that means I start at 2, right?
Yeah.
I start at 2, and then I go down 3, right 1. Down 3, right 1. Ta-da! So I want you guys to graph number 2 on your own. Number 3, x equals a number. Is that a vertical line or a horizontal line? Vertical. It's a vertical line. You need to know that. If it's a vertical line, what's the slope?
I don't know. 0. No, undefined.
Undefined. Okay, so I'm going to go over to where x equals 3, right here. That's where x equals 3. And I'm going to draw a vertical line.
X equals 3.
All right, number 4. Is number 4 in slope-intercept form?
Yes. No.
No, it is not. What do I need to do to make it in slope-intercept form?
Put it in the y and divide by everything.
Subtract 2x.
Subtract 2x. And then what?
Divide by 4.
Divide by 4. Do I divide everything by 4?
No.
Yes. So I have y equals negative 2 divided by negative 4 is going to be negative 1 over 2. And then 8 divided by 4 is 2. So then my slope is what?
1/2.
Negative 1.
Up 1, right 2.
Down 1, right 2.
Okay.
And then our y-intercept is at 2. So we start at 2. And then we go down 1, right 2, down 1, right 2.
Calm down, Gigi.
I want you to try number 5 on your own. Okay, what about number 6? Is number 6 a vertical line or a horizontal line? Horizontal. Once again, you need to know that. You need to know when x equals a number, it's a vertical line. When y equals a number, it's a horizontal line. Like instantly, you need to know that, okay? What is the slope of a horizontal line? 0. Okay, you also need to know that, okay? So that means I'm going to go up to 3 on the y-axis and then draw a horizontal line through it. Okay, so on number 7, we have a system, meaning we have more than one equation. So it says graph both lines on the same axis and find the solution. So remember, when we're solving systems by graphing, we're finding the point of intersection between the two lines. So for the first line, it's y equals x minus 3. So what's my slope of my first line? 1. And what's my y-intercept? -3. So I'm going to graph that. I'm going to start at -1, 2, 3. And I'm going to go up 1 over 1. And with systems, that's the only one I'm ever like, I like to have all the points. I hate doing all the points when the slope is 1 because it's like insane looking. But I like to have all the points because these two lines are going to cross at some point. And so I want to make sure that my graph, my line is accurately, because like obviously you can tell my line was terrible. I didn't go through the points. So I like to have the dots so I can know where the points are.
You can hold down the end of the line and it's straight.
You can with Notability. And this is explain everything so I can film. And I can't do that. It's terrible. Look.
You can't do that.
It's very sad. I know. Is the second equation in slope-intercept form? No. So what do I need to do to get it there? No, not minus x, because x is already negative. Add x. Good. So then we have 5y equals x plus 5.
Is it 1 over 5?
Mm-hmm. So then we divide by 5. And yes, there's a 1 in front of that x. So we have y equals, I always bring the fraction out so I can see the slope. So 1 over 5x plus 1. And so my slope is what?
1 over 5.
Good. And my y-intercept is 1. So I go up 1. There's my y-intercept. And then I go up 1. Right, 1, 2, 3, 4, 5. 1, right, 1, 2, 3. Okay, I can't go that way. Down 1. 1, 2, 3, 4, 5. Do we feel comfortable going both ways with our slope? So if we need a point on the other side, instead of going up and right, we go down and left. So then I have 2 lines, and they should cross. If they don't cross, what would the answer be? No solution. But these ones do cross. They cross right here. So we're just going to find where that is. 1, 2, 3, 4, 5, 1, 2. Good. So my answer is 5, 2, and we always write it as a coordinate point. So we should be working on number 8 on our own, trying to solve the system by graphing. Still stuff that we have done before, but we're just going to do more practice with, is graphing inequalities. So this is where we graph and then we shade. Okay, when it has an inequality symbol, we graph and then we shade. So we need to determine whether it is solid or dashed and whether we shade above or below and all of that stuff.
Solid.
So this one, yep, this one is solid. Why is it solid?
Because there's a dash.
Because there's an equal sign underneath the inequality. Good. And then I also need to check and see, is this already in slope-intercept form or do I need to solve?
It's already in slope.
It's already in slope. So what is my slope?
Negative 1 over 2.
-1/2. And what is my y-intercept?
Negative 3.
-3. So I'm going to graph my line like normal since it's solid. So I start at -3 and I go down 1, right 2, down 1, right 2. Unless like you run out of room, you know, and then you need to go left. But yeah, normally you'll start off going right.
I'm going to 1.
Okay. And then now, do you guys remember how we decide?
Oh, plug in 0.
Good. So we pick any point that's not on the line. I always pick 0, 0 because it's the easiest one to remember. So I'm going to pick 0, 0. So 0, 0. And you're going to plug that in for x and y to your equation. So I have 0 is less than or equal to -1/2 times 0 minus 3.
So only where the letter is. You don't plug
Yes.
in -1/2.
Correct. So on the left, it's just 0 is less than or equal to. -1/2 times 0 is 0, right? And then 0 minus 3 is negative 3. Is 0 less than or equal to negative 3? No. So this is false. If it's false, listen. If it's false, do I shade on the side that the point is or on the other side? The other side. So that's why I always plot my 0, 0 so I can see where it is. And then I shade on the opposite side of them.
Like this. False.
I want you guys to try number 10. So you need to put number 10 in slope intercept form. And then I want you to look at the board and make sure you did it right. And then you're going to graph it. Okay? Is this one going to be a solid line or a dashed line? Dashed. Okay.
Does that have to
So now we're going to talk about systems of inequalities. So systems, hey, are we listening? Systems is when we have two lines that intersect, right?
Yeah.
And inequality is when we have less than, greater than, and we shade. So we will be shading two different lines and seeing where the shading overlaps. So our solution is all the points, I'm going to say the points in common or where the overlap is. Where the overlap is. So basically, each problem, we're doing 2 inequalities in one graph. Okay, 2 inequalities, one graph. Yes?
Sure.
So if we look at number 1, we've got 2 equations. So this is where I've been doing where I do my graphs in 2 different colors and I shade in 2 different colors, or you can do your 2 lines in the same color, but then your highlighters you will use to shade each piece, okay? So my first line is y is less than 2x minus 5. So is that going to be solid or dashed? It's going to be dashed. And then what's my slope?
2x.
2 over 1. And what's my y-intercept?
Negative 5.
-5. Okay, so let's graph that. So we're going to go down to 5, plot our point, and then we're going to go up to right 1, up to right 1, up to right 1. Okay? And it's a dashed line.
Oh, shoot. Can I just do a little dash side?
And then I'm going to pick my point 0, 0, and I'm going to plug it in. So I have 0, 0. So I have 0 is less than 2 times 0 minus 5. So 0 is less than negative 5, which is false. So we're going to take one of our highlighters and we're going to shade on the side opposite. So this side.
And
Okay.
you do this twice.
Yes.
And that's all you need for the answer.
So we're going to do the other one. So is the second equation, y is greater than negative x plus 4, is that one going to be shaded or dashed? Dashed. You could have one shaded and one dashed. That is allowed. Normally, they'll both be the same, but it's possible to have one of each. And what's my slope for the second equation? Negative 1 over 1. And what's my y-intercept? 4. So I'm going to go up to 4. And then I go down 1, right 1. And it's dashed.
Is there is the point where it crosses relevant at all?
No.
Can you pick the same point?
Yep, we're going to pick 0, 0 again. As long as it doesn't fall on the line, you can pick it. So then we have 0 is greater than negative 0, which is just 0. There's no negative 0. 0 plus 4. So 0 is greater than 4. True or false? False. So this is where we take our other highlighter color and we shade on the other side.
Is that it?
Uh-huh. Now, where we overlap, so over here where it overlaps is our solution.
What if it doesn't overlap?
It will.
Wait, so
Something that I could ask is I could say, okay, so here's my graph, right? For this system of inequalities is, and I'll do it in orange, is 4 to a solution, okay? So I would go over to 4, I would go up to 2 and plot my point. Is that point in the overlap? Yes. So yes, that's a solution. Yeah? So that's how you could ask, is you could say is this a solution? But what I'm grading specifically here is just, can you graph it and is there overlap in the right place? Is negative, actually let's do is 1, 5 a solution? So over 1, up 5. It's not in the overlap, so no. It's not a solution.
So is our answer just the graph?
So in this lesson, the answer is, I'm just checking to see, did you graph the lines right? Did you dash them? are your shadings in the right spot? Does your overlap go in the right spot? Yes.
But when does
But like application wise, what's the point of this is for me to say, okay, are these points in the solution? Are these points in the solution? Are these points in the solution? And you're just like in the solution, meaning are they in the overlapped area? And so that's why I graphed it. So I said is 4, 2. So if you go over to 4, up to 2, oh yeah, it's in the overlap. But 1, 5 is only in the red section, so it is not a solution.
If you have a question, will you ask for what?
Okay, I want you guys to try number 2, but number 2 you have to solve both equations for slope-intercept form. Ready, set, go.